We talked about how to find domain and range for discrete relations, but let's talk about how to find domain and range for continuous relations, specifically finding domain and range from a graph. So for this activity, this is where you can write down what the domain and range is. But turn the page and you will see here are your graphs that you're going to look at. So let's take a look at number 1. We want to find the domain and the range of this graph here. Well, I know it's a line. I know it's, y equals mx plus b. I know that these arrows mean that technically this, this relation or this function continues on forever in both directions. And I know that the domain are my x values and the range are all of my y values. So I take a look and I say, what is possible? What are the possible x values? Let me do my domain first. What are all of the possible x values that I could possibly get? Well, I could get 0. I could get really any positive value, right? I could get integers, I could get fractions, I could get really any negative value. Integers, fractions, decimals, icky ones, nice ones. I could get anything. So in this case, my domain, I would say, is all real numbers. And real numbers meaning any number at all. Integers, so nice whole numbers, fractions, decimals, square root of 3, I could get that. So all real numbers, I could get any of them. And sometimes I just personally like to abbreviate it, all real numbers like that. And then for my range, what are all of the possible y values that I could get? And again, I'm looking, I could get all of the positives, integers, fractions, I could get 0, I could get all of my negatives, and these would continue all the way up to these really high numbers and continue down to these really low numbers. So again, my range is all real numbers, or if I want to abbreviate it this way. Generally for lines, when you have a line, you're going to get all real numbers for your domain and all real numbers for your range. You can plug in any number at all that you want into the rule for a line, and it's possible, and as a result, you're going to get pretty much any value out as a possibility. So that's a case where any number can be the domain and the range. Let's take a look where it's a little more, let's see. Now here we do have a line, but if we notice, we have a vertical line. So I know that the domain is all of my x values and my range are all of my y values. So let's take a look at all the x values that I could get. I have no x values over here. I have no 0. The only x values I'm ever going to get are along this line, and it's negative 1, 2, 3, 4, 5, 6. Negative 6. That is it. The only x value I can plug in is negative 6. And my y values, no matter what I plug in for negative 6, I can get positives, I can get 0, and I can get negatives, and I can get integers, whole numbers, I can get these little fractional guys. So my range is all real numbers. I can get anything for my range, but for my domain, I only got negative 6. That is the only thing, only x value that I have. Let's do another line. So here we have another line. This time it's a horizontal line. I think you can maybe predict how this one will be a little similar to number 2. My domain. Okay, so my x values, I can get all of these negatives, I can get 0, I can get all of these positives, I can get anything. I can plug anything in for my domain, so all real numbers. And then my y values, what comes out as a result? Well, I get nothing here, and I get nothing here. All I get are all of these values along here, and that is negative 1, 2, 3, 4. I am only going to get out negative 4. So no matter what I plug in for x, The only thing I get as result is -4 for y. Now I have a negative x over here, and I just get a -4 for y. And let's do one that is not a line. Here I have a parabola. This is going to be an x squared equation. So let's take a look at my domain and my range. This looks a little different than a line. Well, let's take a look at my domain. Domain are my x values. And let's see, I know that these values are going to continue on and on and on and on forever. So it looks like it's pretty narrow at this point, but remember, if we continue on for infinity, because that's what those arrows mean, this parabola will continue to get wider and wider and wider and wider and wider. So really, for my domain, I could plug in any x value. I could do any x value at all, so all real numbers are okay. Even though they're not showing up on this graph, those arrows tell me that it will continue, so that it will encompass all of the possible x values. But let's talk about my range. My range are all of my y values. Now, I know that I'm going to get all of these y values, right? And all of these ones going up, and all of these positive ones going forever. But will I ever get any of these y values? I won't, because the minimum point of my graph is here, and then it just increases. So I will get nothing, I will get none of these ones. So let's see, so I'm going to have my y has to be greater than or equal to, let's see, this is -1, 2, 3. So -3 will work, but it has to be bigger than or equal to -3. So my y values are only going to be larger than, greater than, or equal to -3. I will never get anything smaller than -3 as a y value for my range. You go ahead and finish out trying to find the domain and the range for all of the rest of the graphs.